Hi, welcome everybody. Today we will have a class on mathematical induction. This is class number 2. In the previous class we have discussed the procedure to prove a mathematical statement using the principle of mathematical induction. This is the step-by-step procedure. I repeat once more. Step number 1 is we write the given statement as P of n. Step number 2, we prove that the statement is true for n equal to 1. That is, we prove P of 1 is true. Okay. Step number 3, assume that the statement is true for n equal to k. That is, P of k is true, we assume. And what is step number 4? We prove that the statement is true for n equal to k plus 1. That is, P of k plus 1 is true. Therefore, the statement is true for all natural numbers. This is the step-by-step procedure. Let's see the question. Sigma I varying from 1 up to n of I is equal to n by 2 times n plus 1. How will we prove this question? By the principle of mathematical induction. Now, when I expand the sigma notation, this is equal to 1 plus 2 plus 3 plus etc. plus n is equal to n by 2 times n plus 1. That is, this is the sum of the first n natural numbers. We can write the question in the other way also. Prove that the sum of the first n natural numbers is equal to n by 2 times n plus 1. Okay. Now what is the first step or the first procedure is we write the given statement as P of n. What's our P of n here? P of n is sigma I varying from 1 up to n of I is equal to n by 2 times n plus 1. Okay. Now move on to step number 2. What is step number 2? We prove the statement for n equal to 1. That is P of 1. What is our P of 1? That is I varying from 1 up to 1 of 1 is equal to 1 by 2 times 1 plus 1. That is 1 is equal to 1 by 2 times 2. That is 1 equal to 1. Both the left hand side and right hand sides are equal. Therefore, the given mathematical statement is true for n equal to 1. Okay. Now what is the next procedure? We assume that the statement is true for n equal to k. That is P of k. What is our P of k? P of k is sigma I varying from 1 up to k of I is equal to k by 2 times k plus 1. Now using this statement, we will prove that the statement is true for n equal to k plus 1. That is, in the statement for P of k, I am going to add k plus 1 on both sides. Okay, the sigma I varying from 1 up to k of I is plus k plus 1 is equal to k by 2 times k plus 1 plus k plus 1. Now I am going to simplify the right hand side only. Left hand side keep as it is. To simplify the right hand side, it is equal to k times k plus 1 plus 2 times k plus 1 upon 2. Now take the common factor outside. Which is the common factor? K plus 1 times 2 I am taking outside. K plus 1 times 2 times k plus 2. This is the right hand side. What about the left hand side? The left hand side is the sigma I varies. So this is the same as sigma I varying from 1 up to k plus 1 of I is equal to k plus 1 by 2 times k plus 2. Okay. That means the result is true for n equal to k plus 1. And therefore, by the principle of mathematical induction, the result is true for all natural numbers. Okay. You can verify yourself. Tell me any natural number. 3. Okay. Let us verify for n equal to 3. Now in the given mathematical statement, I am going to put n equal to 3. That is sigma I varying from 1 up to 3 of I is equal to, on the right hand side I have to put n equal to 3. Okay. 3 by 2 times 3 plus 1. That is, the summation on the left hand side will be 1 plus 2 plus 3 is equal to 3 by 2 times 4. Okay. That is 6 equal to 6. That means the given statement is true for n equal to 3. Now let us verify for one more natural number. Tell me any other natural number. Let us verify for n equal to 5. Okay. Put n equal to c. The result is, or the mathematical statement is true for n equal to 5. Let us verify. It is sigma I varying from 1 up to 5 of I is equal to, put n equal to 5. 5 by 2 times 5 plus 1. To find the summation I varying from 1 up to 5 of I. What are the terms obtained? First term is 1, second term is 2, third term is 3, fourth term is 4 plus 5 is equal to 5 by 2 times 5 plus 1 is 6. That is equal to 15. When you add 1 plus 2 plus 3 plus 4 plus 5, that is equal to 15. Okay, 15 is equal to 15. That means the statement is true for n equal to 5. You can check it with any natural number. Try by yourself. Okay, we will stop today's class. Thank you.